Hello everyone, I'm Samia Sharman Sara and today I'm going to show you how to convert a C code to an MIPS code. Before starting that, I'd like to thank my friends Novasen Shabab and Mahfuzara Proma who have helped me in making the video. So here's the C code of the problem that we are going to convert it to MIPS, which is GCD, the greatest common divisor. And to convert it to MIPS, we'll have to open the Mars simulator that I'm using. So let's just open a new file, which is file new, and as you can see, a new file has been created. First of all, we'll have to save this file, Control S, and then name it whatever we want. I'll name it GCD. So here's the file that I'm going to work on. In C code, as we can see, that first task is taking inputs, and we'll do the same in MIPS. So first of all, we will store those two values that we are going to find GCD of, and we'll store those values in register A0 and A1 because these registers are used for sending as parameters, sending values to parameters. So I'll write add I, which is add immediate, register A0 and then 0 and then 1. This line means I'll be adding 1 to the value stored in 0 register, which is 0, and then storing it to the register A0. And actually I'm storing the value 1 that I'm going to send as parameter, and similarly I'll store the second value, which is 4. So this line means I'm storing 4 in the A1 register. So I have my two parameters ready. So here, as we can see, the second task is function calling. So we'll call the function here, which is GCD, and for function calling we'll use this chal instruction. Chal means jump and link. So jump to the function, which is GCD, that I'm going to write later, and link to the immediate next address. We have a register called RA, which stores the value of this address. So in this address we will write something later. So first let's write GCD. This is a label. When this chal function is called, GCD means the function will now go to GCD label, and what we are going to do here is write these conditions. So the first condition is A greater than B, then A less than B, and the last one is A is equal to B. So we'll start with the last one, which is if the two numbers are equal. So what we are going to do is B equal, branch equal A0 comma A1, done. This line means if A0 and A1 are equal, we will jump to the label done, and if they are not, then we'll go to the next line, which is BGE, which means branch greater than A0 greater than A1. Then we'll jump to the function, anything we want to name, AGB. And even if this doesn't work, then this is the else function, which is subtract So this line means subtracting A0 from A1 and storing it to A1. Look carefully, these are the three conditions that we have done in SQL. Seems very small, but these are working very efficiently. And actually this branch equal and BG are not just the actual codes or actual instructions. These instructions have three other instructions that we are not showing right now. So this first condition is if they are equal, then we'll jump to the done label. The second one is if A0, the first number, is greater than the A1, we will jump to the to another label which is AGB, and if none of these conditions are true, then we will subtract A1 from the A0 and then store it to A1, which means either way we are just subtracting. So we're done with this conditions, and then this is a recursive function, so we will jump back to the GCD, which is the function that we have written. So now the AGB label, we are going to write here what we are going to do in AGB. In AGB, if A is greater than A1, what we are going to do is we are going to subtract A1 from A0 and store it to A0. So we'll use sub function A0, then 0. So this line means we'll subtract A1 from A0 and then store it to A0, and then we're done, and then we'll call the GCD label again, as it is a recursive function. Then we'll write what we'll do in done. So here's the done label. What we are going to do is, done means A0 and A1 are equal, which means we don't need to subtract anymore. So what we are going to do is add B0 to 0 and 0. This line means we are storing A0 in the register V0. Why in the V0? Because V0 register actually returns the values of functions. So when we are writing return A in C code, we are actually returning the values from register V0. So we are done, and then we will jump to RA. This RA is the register that stores the value of this address. When we called JAL and GCD function was called, this RA register stored the value of the immediate next address. What we are going to do here is jump answer. So here I'm going to write another label, which is answer. So we have converted this entire C code into MIPS. So let's just run it and see if we are right or not. So run, assemble. So here it is. We have used the register A0. We can see its value is 0 here. Then A1 is also 0 here, and V0 is also 0. The numbers that we used is 1 and 4. You can see that A0 has now 1 and then 4. We will see that after running. This button runs the entire code at once, and using this button we can run each step at a time and see what actually is happening. So I'll use this run one at a time. So after running for the first time, you can see this A0 has become green and A0 has the value 1, which means the first line that we executed was storing 1 in the register A0. So we'll click for the second time, and we can see A1 has the value A4. So we have successfully stored these two lines. Here's the line 3, JAL GCD. It will call the function GCD. So we can see that our A has this something address. So as I said, JAL function calls the function, jumps to the label, and then links, and which means storing the next address. And we can see that our A register has the address of the immediate next register, immediate next command. So after that we will run it again. We can see the branch greater equal A0 A1, which means A0, it will check whether they are greater or not. Then nothing has changed again. Now we can see is AT. We haven't used this register, but still it has come. That's because BG is the B equal or branch greater than equal. These instructions that we are using are not just unique. instructions. They have multiple instructions. So after that we'll go to the subtract this, and then it goes a1 is equal to 3, which means the subtraction has been done because the second value was greater than the first one, so which was 4, and 4 has now become 3. We have subtracted. Now it has gone back to the function gcd again, and then they are checking these conditions again, and now we can see that a1 has become 2. Now it is decreasing. So again run this, and we can see a1 is 1 now. Now a0 is 1 and even a1 is 1. So let's run it again, and b equal branch equal a0 a1. So a0 and a1 are equal, so we are now done. So we have now gone to this command, which is add b0 0 a0, which means we are storing the value of a0, which is 1, in the register v0. See, the value of v0 is still 0, and when I'll click this, it will become 1. So here we can see this value of v0 has become 1 now. So that's all for today. We have now seen how to code in MIPS. So thank you for watching.